Hey, it's James from Finney Electrical. On today's episode, we've got an EICR. So it's the last orders for an EICR, and it's coming up. Let's get into this. So into the property now then. So this customer is selling the house. So yeah, nice lovely view. It's alright, isn't it? So yeah, we've got this whole property to test then. So we're going to dig into all the electrics then. So we're going to basically disconnect the cables out the fuse board, send some voltages down them, and it'll tell you if you need a rewire or not. And then things like metal fittings and metal switches, we need to make sure that they're all earthed, and we basically get a earth reading at every point. So first things first then, so step one, we're going to do a visual test. Straight away then, as you saw in the beginning of the video, we've got an indoor fitting. It's a non-waterproof fitting in the bathroom. So obviously it's going to get quite steamy in here, the steam's going to rise. There's no fan in here either. If you look, so they've had this bathroom done out, no fan. Oh sorry, there's a wall fan actually. But the steam's going to come over this light and then exit, so not very good really. This is what it looks like when I'm filming. But yeah, so this will have to get swapped out for like an IP one. Yeah, it's just not waterproof, so it's not very good, and it does land within the zone as well. So there's basically bathroom zones where you're allowed to have waterproof fittings and non-standard fittings, and it lands within that zone. So what else we got then? So there's lots of downlights, so we should check the terminations of them, make sure they ain't got loads of singles exposed. That's the same fitting there, so I think they just bought two fittings, shove one there, shove one in the bathroom, because it does look nicer than a plastic dome thing, but it's not waterproof. Maybe that should have gone in the bathroom. That is an IP fitting. We're also looking for cracked switches, quack, like a duck, cracked sockets, and yeah, we'd have to identify that and get that swapped over, because basically that crack, it'd go down as, there's different categories. So you get C1, where basically it's like live parts, you can poke it and get electrocuted. There's a C2, it's a potential for fires and electric shock, like a crack socket. That would be a C2, because the crack's there, and then say you plug in and you plug out, and then it, like the face comes out because it's got thermal damage, and then you got exposed parts where you can poke it and die. So yeah, we don't want that. And then there's C3s, which are like recommendations. You might have like the regulations might update, and some regulations don't retrofit. So stuff like a plastic fuse board, you won't put that down as a C2 where it'd fail, you put it down as a C3. That's a recommendation, just saying the regs have changed, but you don't have to get it done to pass the report. But if you did want everything up to date, you could do. So there we go. So straight away on that visual then, we've got the RCD. We've got cooker sockets, so the sockets are to be protected. But stuff like circuits in a bathroom, like your lighting, that would have to be RCD protected as well. So what we'd have to do then is move that over to the RCD side, and then that would cover it. So just stuff like that, you know what I mean? So we try and work with landlords, because a lot of people will just come in and go, plastic fuse board needs replacing, and they'll do a fuse board changeover straight away, and they'll be in and out in less than an hour. So not good, but yeah, we're here generally 3 hours-ish for a standard install. If it's really messy, it might push 4 hours, because you've got to dive into it, unterminate and re-terminate it, and follow out which earth goes where, so it could be a bit of a nightmare. So right, I'll stop waffling on, let's get into this. We're going to open that fuse board up, get everything tight, and then start testing. Right, got a slight issue then, so it's been sealed in, and these lids probably go back about that deep, so we're gonna have to just prise this baby out. So hopefully it doesn't wreck any of the brickwork, it's just like a brick clad. Hopefully we can get the board off. Right, that took some doing that. I'll just slowly prise around it, so that should go back on alright. We've got a nice little silicon rim now, so we'll take that off then. So what we have to do then is get all that tightened up then. So it looks fairly neat, this fuse board. Doesn't look too bad. A few new circuits being added. You can see where they've done that, but it's literally recessed into the wall. So interesting one really. But yeah, what we're going to do then, I'm going to dive into all the circuits. Obviously get everything tightened up, I'm going to take out a circuit at a time, do an insulation resistance, and do a continuity test, and then bang it back in. So that's as dead tests. And then what we're going to do is live test. We're going to get ZE. So that's a live test. That's basically getting the resistance from the line to earth all the way back to the transformer in the street. And then we have to get an RCD test, make sure this RCD is tripping him in certain times. And what else? Well, that's about it really. PFC, that's the other one. But yeah, we'll go through that. Alright then, so we'll do the ZE then. So what we're going to do then, so we'll bring it on high current. We're going to disconnect the earth. We have to turn everything off then. So disconnecting the earth. There we go, that's everything off. And then what we're going to do is take out the main earth coming in. That disconnects all your parallel paths, and then you do an earth test from the earth going out to the line coming in. So we'll crocodile clip that, bang it on live, and that'll be your ZE. So obviously it's got the worst case earth readings, because you want to make sure that your earth coming in is not the pipes being bonded into the ground. So if that's your only earth and the earth coming in wasn't your earth, it just nothing, then they'll tell you that by doing that, by taking the earth out. A lot of people just do the test straight away. So they'll leave the earth in, just go to this bar here to line, and that'll get a ZE. And it might be the same reading, but it doesn't prove that your earth, your big fat earth, your main earth, is actually an earth. There we go, a bit of a balancing act, so 0.45, so that was with the earth out. So I'll just bang it back in. Now what we're going to do is do a test with the earth back in. See if we can sort this. So we should get a slightly better reading, because you've got other parallel paths to earth, and if you look here then 0.38, so it's slightly better path to earth. So it's improved it by quite a bit. But obviously what we're going to do, the whole point of that is to get this reading. This is the PFC, so 626, that's in amps, so it's going to be, you write it in kiloamps, so you divide by 1,000, so it's going to be 0.63 then, which is going to be that reading for the PFC. So that 0.45 is quite high for a TNCS system, so I might have to look into the connections of the main cables coming. You know where the meter is, the white box on the outside. I'll have to look in there and just make sure everything's tight, because it's a little bit high, that. So I might have to flag that with the DNO. As we know, it's 0.35 is the max ZS you can have, so 0.45 is well over. So it'll just basically cause some issues as well when we're testing, because obviously we've got a maximum reading we can have where we add that number to the circuit's resistance, and if it lands over a certain max ZS number, it's called, then it doesn't pass, and we'll have to downrate the breakers. I'll look at upgrading the earth, which nobody ever does, because it doesn't make sense to do that. So yeah, we'll have to look into that to make sure everything's going to land within them readings, them max ZS readings. RCD test next then, so what we'll do is bang that on RCD time. There we go, RCD time, and it's the 3 lead test. So only the neutral as well. So what we'll do is just go on the, so it's obviously the outgoing of the RCD, so make sure things back on. Woof. So what I'm going to do then, so the new regs, the old regs, it used to be like, I don't remember now, but yeah, you test it 1 time and 5 times. 1 time you're testing on 0 and 180 degree of the cycle of the sine wave, and it had to be less than 200. Then for 5 times it has to be less than 40 milliseconds, the tripping time. For this, the new regs, you put it on AC only. You can forget about the type A setting, because I used to put it on, so it's like a little squiggly line for AC. I have to put it on the type A. So you put it on AC, 30 milliamps, and you only test it on 1 times on the 0, on the 180 degree, and basically you want to be less than 300 milliseconds. So they've upped it a little bit, and basically if it lands within under 300 milliseconds of it tripping, it'll pass. You have to do a bit of finger gymnastics. So we've got the earth in there, neutral there, so I just go dead earth, then neutral, and then put my line on, then press test, then use my right hand to reset it every time. So it's still easy to put it on the auto, to be fair, when it does do 1/2 times and 5 times. But if you look, that's your 5 times. So it needs to land less than 300, and you write down the highest reading, so that's 0 and 180 degree of the cycle at the top. So we're going to write down 33.5 for that RCD then. So then we're just filling out the circuit details and test results. So what I do is just fill out what we can. So we're going to make some assumptions on things passing, and then if they don't pass, like the insulation resistance, and we'll change the answers here. It's a lot quicker doing things in bulk, where you can just quickly like copy paste, and then change it if it does change. So then what we've done is, same again for the number of points. So like an alarm, we've put one point, cooker 1 point, so on. So the bits we know. If it does change and there's more points, we'll add it. And then the cable size, what I do is just take a picture of the board then, get a nice picture of that, and duff, and then you're just looking at you can zoom in on your phone, and then comfortably fill out your report without like having your head sideways on the ceiling to try and guess the sizes. So a little bit easy for you. Just yeah, take pictures of the board. Definitely like a big board, like a 3-phase board. You know, we get a nice side shot, top and bottom, right, top right, bottom right, and then you can sit there at a table just typing in all the details. Obviously, we're going to check all that. But yeah, let's crack on then with this first testing and this first little circuit. Right then, so I've just checked to see how far these are tight. So you've got to use your torque screwdriver and get it to the right setting, get it tight so it clicks, and then you know that they're all tight enough. But yeah, they're well tight. So, but yeah, what we're going to do then, so we're going to test the cooker then. So we're just going to link out that first. So we'll go line to earth like so, onto there. So I'm going to test the circuit's resistance sensor. It's going to test the line going out to into your circuit. We're going to test right at the end, and then we're going to put it on continuity, and we're basically going to test the line and earth that come all the way over here to the cooker switch, which is here, and we're going to test between line and earth. And then we're also going to test that if these two appliances come off that, we'll check that that's earth just by, I've showed it in a previous video, but you can put your line there and then literally put your probe onto the metalwork and see if you get a result, So if you get a nice low reading, and there's not much difference in earth reading between this and that, it means you got good connection. Now if it's the same earth reading, but I'll show you that. There we go, breakout box then, continuity. I think, let's have a look, let's see if these are nulled. Yeah, so they've been nulled already. So I'm going to just plug this in, turn him on. I'm going to do line to earth, so earth is that one, line is that one. Press test. There we go, 0.11, so that's nice and low. Let's just give them a little wiggle. Sometimes the contacts can be bad. There we go, 0.08. We've just gained 0.03 less, so that's good. And then what we're going to do then is still keep the line in there. I'm going to go line to earth still, but we're going to put it on the metalwork of this and see if we get a reading. And we do 0.06, so that's super low. And that's sending in for this. Yeah, we're getting a reading, 1.97. So maybe the metalwork on this is not as good. So sometimes it's better to find like an internal screw to get a slightly better reading. There we go, so I've actually gone onto like a metal screw in there, which has got a better connection with the whole full bodywork, 0.12. So we know that these two appliances are earthed properly, and we've got a reading for that circuit. There we go, I've just written that in then. So we've got 0.57 is 0.12 was the dead test, R1, R2. So it's R1's your line, R2 is your earth. So it's them added together, which is what we've just done by linking that up there. All you do is just add on that 0.45 from earlier from the ZE, and that gives you 0.57. So this number here, 0.57, is to land under this one. So not 1.09. Now, if we make that higher, let's put it on a 40 amp, you see it's giving us a lot less tolerance. We've now got 0.87 it has to be under. So say you're struggling for a reading. So if this is getting quite high or goes over, and it wasn't by much, and it's just because of the length of run rather than the tightness of connections, you could just drop it. So if we put that on a 20, if you look there, it's gone 1.75, so it's giving us an extra like 0.6 ohms to play with, which is loads. So a nice little tip there for you if you've checked all your connections throughout the circuit and you're still getting high readings because of the length of the run, because it wasn't designed properly, you can downgrade your breaker and it gives you a bigger maximum ZS. Any top tips for Finney Electrical then? Alright, so what I'm going to do then, I'm going to bang that on insulation resistance. And then we've got line, earth. There my earth died. My line, crocodile clip died. I'm on that fancy house job with my pocket, and I think it was the wire to the laptop, and it just snapped it. It pulled on that and went, so I'm a bit sad about that. I'll have to buy another one, but they're like 30 quid or something stupid. Right then, so line to earth test. I'm disconnected the neutral, so it's not going to kind of pick up the RCD or any other circuit issues. So greater than 200, great. Now I'm going to go neutral to earth, and it should be the same to be fair, because it's obviously running through the appliance as well. But there we go. So that's spot on. So that's about as good as it gets. So a lot of the insulation resistance, you can't take out all the loads. Obviously, if you to test down the line to earth, that's going to sort out them two. And if you test from neutral to earth, that'll test between them two. But yeah, like something like downlights or stuff like that, you can never test between line and neutral, because you have to take out every single light bulb, which would be a nightmare. And yeah, it's basically like doing a second fix on the full property if you did that, if you took out every downlight. Definitely with the ones without light bulbs and it's an integrated downlight, you'd have to actually unwire it all and then rewire it all, which no one's going to do. Here we go, these are the insulation resistance tests then. So a lot of these are 120, greater than 120, so anything over 1 meg, it won't start tripping a brake. Obviously it gets less than like, I don't know, into the tens, then you're like, right, the cable's breaking down enough where there's going to be an issue, or there could be something plugged in that there's an issue with. But here we've got 0.12, so because it's on the non-RCD side, so the main switch side, nothing will happen, it'll just run forever. But there's obviously 0.12 to, you know, it's escaping somewhere. So there'll be quite a bit of earth leakage most likely on that circuit. So if the circuit was perfect, you won't get anything between. So there's something going on there, and it's on the heating circuit. So I think if we put that on RCD, the heating circuit, it'll start tripping out. So from experience, yeah, anything over 1 meg, if you're like 0.8 or whatever, and you power it up, it'll just have intermittent tripping, which can be a bit of a nightmare. So obviously we're not going to do that. But yeah, obviously it's just a recommendation for RCD protection on all the other circuits. But if you got on existing circuits, but yeah, if it's socket circuits from the bathroom, then it needs to be RCD protected. Really, it'll be a C2 and you'd have to get it done, so otherwise it won't pass the report. It'd be interesting to see what you would code this then. So we've got a neutral bar there, so the old plastic boards, it was these like little pushing plastic clips that you just plugged in, and then that actually held the bus bar in. So what would you code that then if you've just got a flappy neutral bar? You can let me know below. Right, so part of the test then, part of the visual test. I'm gonna check for bonding. There we go. Don't see any bonding, but I bet that it's I can see some cables coming out the board, but I bet it's bonded that side behind that brick wall. So we'll have to get a test 2 here, and if it's low, then like under 0.05, we can maybe make the assumption that it's on. But it's not great, is it? If not, what would you do? You'd have to. So I had that with APIT in the past, and they just said, yeah, if you can test it and it's got a good reading, then it's most likely on, but you just can't see it. So you'd have to just put that down. The other option would be so you can see it, would be to chop into this, put a little MET on, come under through to this one, and then get a little clamp on there so you can actually see the connection, and then you know it's on then. So again, what would you put? Tell me what you'd do in the comments below. So this is an interesting one then. So look, so I've just filled it out. I've got a template. It fills it out as 100 amp, and we change it if it's different. 100 amp TNCS. It's a TNCS, but look, 60 amp. Look at that. So it looks like when they were building this big estate, they've the grid's not happy with them having 80 amp each or 100 amp. So 60 amp's nothing really. So if these want EV chargers, they're going to be screwed, aren't they? So we're going to have 40 amps for EV charger, and then 32, and then it only leaves another 30 amp, which isn't a lot really. If you got electric showers and electric appliances, not good. Oh, absolute sweaty. Right then, let's go on to some circuits then. So we've done the radial, I've showed you a radial. We're just doing the socket circuit now. This was doubled up in the 32. Now I've just popped that out so we can see what's on with that and what's not on with that. So all the rest of the breakers are off apart from that one. I'm just going to go around and get a ZS just so we know what we're going to be playing with. We can even write that reading in. And then what we're going to do then is disconnect the circuits and do a ring test. So it's an end-to-end test. We'll go through that shortly. Insulation resistance, all that jazz which you've seen already. So it's killed these. Now obviously one radial on 32. It bees off into this socket behind there, and a socket on this wall. So already, just by doing that, we've just proved that that's basically, you can only come off once off a ring, and even coming off the break is a bit dodgy. But yeah, that one 2.5 cable can take about 27 amps. So obviously if it's on 30 on a 32, it could be running at more than 27 and set on fire. So that's why they only allow one socket to come off. So, but yeah, it's got 1, 2, 3, 4, 5, and that's off the kitchen, off the downstairs sockets. So yeah, that's gonna have to get put on its own 20 amp circuit. There we go, so it's a good job we're testing it, because that could have been a big fire risk there. So what we're gonna do now is just go around then, we've only got one circuit on, so anything live has to be that circuit. So let's see what it is. It's not this one, so we'll just go around and see what's doing what then. So that circuit then, it does just random sockets around the house then. So there's nothing this side, the kitchen or this side. There's all the sockets here. It does the, not the back room, but that top up room. It does the front bedroom, and then one landing socket and the underfloor heating there. So it's a bit random, that and that one. So yeah, sockets, we're gonna call it that. Normally you put like sockets up, sockets down, but they're just wired, a bit random really. So it's a bit all over. So right then, what we'll have to do then is put on that report then that this circuit here will need to go on its own breaker. There's spare ways here that we can fit it in. So we'll just say DB1 circuit 11, new coloured cable, radial needs going on B20 position 13, something like that, and that'd cover that one off and make it safe. So now we're going to do a ring test then. So obviously when you wire the cables to the ring, you've got 3 cables at the fuse board this side, it goes round all your sockets, and then it ends up 3 cables back. Sorry, 3 cores are live, earth, neutral. So what we're going to do then is test between line to line, neutral to neutral, earth to earth, and you should get a reading all the way around. So that's the first test, and then second test is your crossover. So we're basically going to do the line to the earth on this side and the line to this earth on this side, and then go around and test. I don't know why I've done the testing thing, so I could have just done that then. So waste of time, but yeah, that's I wanted to know what was going on with what, because I didn't like the fact that that was banged in there as a radial, so I didn't like it. So I've taken out line and neutral, and I'm going to take out the earths, and I hate people.
Hate. Double hate. Loathe entirely.
Who put the same earth in the same sleeving, so you can't actually split them to do the ring test. So what we're going to have to do is bang these back in and actually go to a socket on the circuit and split it there, and then do the crossover there essentially. Right, that gets it back in now, so it's got to go. There's crocodile clips. Ooh, yeah, it's all going wrong. Right, get crocodile clips. We'll go to a socket that we're going to test that. We need 2. And yeah, split the ring. Let's pick a nice easy one. No, not a single socket. Single sockets are rubbish. We'll go upstairs, I think. Better. Single. Yeah, there's no room in single sockets, so yes, I'll do. Nice. Yeah, I changed my mind because this is going to get looked at anyway. Look, just a cat plug got in because that there. So I'll actually unscrew that and maybe fix that now. Yeah, we go to the top tip for testing then. Look, the sleeves up the same sleeving. Oh, I hate it. Annoying. Look at that. Right, now they're separated. We can do an end to end. Like I said, these will wire back to the fuse board, that one back to the fuse board, all the way around. One of them will go all the way around and back to the fuse board. So we're going to do an end to end test. So I'm going to clip on one side like that. So we'll do a line first, and then we'll get his earth plugged in and do earth. I'm going to bang it continually. It's already nulled the leads, and let's see what result we get then. So that's on there. Test, there we go, 1.96. So we're getting decent readings all the way around. So let's do neutral, so we should be getting similar readings of 1.96. We're not, so there must be some sort of loose connection on the line. Yeah, 0.5. So that means there's a loose connection somewhere on the line cables. Let's just make sure that's fully on when we did that test. This other crocodile clip is just rubbish. The Fluke official one is actually quite good. It's even worse. Oh. So yeah, we've got 0.5 for neutrals and 0.98, 1.98, so there's a massive difference there. So we're going to have to investigate into that, unfortunately. Or fortunately, because yeah, it's going to need to pass. There we go, that's better. So we've got earths in the same, well not the same sleeving, but not in the same sleeving. So we've done ring test then, obviously, so that. And I'm just screwing this back. So yeah, it wants cross-threaded. So I think they've had the room decorated, and the decorators just screwed in on a funny angle and cross-threaded the screw instead of just doing it properly. taking it out and doing it again. They've just rammed it in and it was sticking out 1/2 inch as you saw. But yeah, that's all back together now. So, on to the next one. So we've got some more observations to add in. So, but fortunately I don't have any golden screws. So we've got silver ones, but you can't really tell, can you? Here we go, here's the lifesaver then. So if you've got loads of like silly fittings, like chandeliers, and you don't want to take off 50 crystals or smash any chandeliers or anything like that, you can get a wander lead. So these are brilliant. So you basically have to null the lead, and then all you do is put a crocodile clip on one end, like so. So your crocodile clip here, you can bang that on the earth bar, like that. That'll do. That's the MET. And then all we can do now is plug your tester into there and do a continuity test all the way around. So for example then, I'm just going to test that light above my head. So we've got the wander lead, whatever you want to call it. For wandering, so it's wander lead. So that clamps on the earth bar, so you plug your earth into this, and then your line into that like normal, and you just test any of the metalwork. So you can find about the screw somewhere. This is a great example, this, where you can't see the screw. There he is. So I'll put it on there. And there we go, you heard that beep. So we know that is earthed. So nice and easy then. So we're just going to go around all the metal switches, all the metal lights, appliances, everything, and just reel out his little reeler. But bearing in mind, if you got it plugged in, it does like to wrap around, so unplug it and then you can reel it out, like so. It's so hard, I need my head mount for this. Put him on, look at that, we've got a beep and we've got a good reading, and so on, and so on, and so on. Look at the appliance, look at that, nice and easy. There we go, easy testing with Finney Electrical. Here we go, great example then. So we've got this old light here. That's an absolute monster to get to. It's quite high ceilings. So just for the R1 R2 test, we've just realised it's not got an earth. Let's check if there's an earth at the switch. And there is. So I bet it's not connected in properly up to the top. It doesn't say it's a class 2 fitting or anything, so it should have an earth there. So class 2 is basically when it's double insulated. And you'll see like a little square within a square. I don't know if Josh wants to put a little square within a square up, show what that looks like. Double insulation or class 2, but yeah. So it just goes to show that, yeah, if you want me to take everything down, because you might have some lazy electricians, you can just R2 it and it'll tell you where the issues are. So you can actually do more than 20% testing on lighting, or 10% or 15, whatever you want to do. You can do 100% R2 and make sure everything's safe. Because you might not pick that as part of the percentage because it's an awkward to get to, and it's not unearthed. So there we go. Look at that, another one then. So we're testing this one, no earth. In fact, it's got that much earth and it's obviously running with a line cable. That, it's got 36 volts, so there's no earth to these. So let's get an earth to these. So let's test this one. Yep, no earth. And there we go, wander lead then. So they're brilliant pieces of kit. So it's worth getting one. You might think, oh, it's a bit pricey when you're first starting out, but just for a test, but it saves you so much time, and it means you can do 100% testing. It only took me about 20 minutes to beat round everywhere, and yeah, so it's found out. So if you're going to say, right, you can do a percentage of tests, you're going to do these ones, aren't you? You're not going to do the harder ones, you're going to take light fittings down. But with that, it means, yeah, you can do the hard ones like that. Well, you can test out that light and prove it's not got an earth. I'm knackered walking around. And what else? The top bedroom light wasn't earthed as well, so we're going to have to record that down and look into that. Get those earthed. And the front door lights weren't earthed either, so not sure what we're going to do with that one. Dear oh dear, so there's a lot of stuff going on here which is not right then. So we'll go through the list then. So we've got the downlights in the hallway then, so it's supposed to be a fire rated downlight. So it's supposed to have like a hood which will basically stop the fire coming through. So when you cut a hole in a plasterboard, it breaks that fire barrier. So what you do is put these downlights in, which will seal that barrier and stop fire spreading quickly. Now they've just installed non-fire rated downlights downstairs, and yeah, there's 17 of those to do. So it's 5 in the hallway, 12 in the kitchen. So that's a bit of a hit when they're like 35, 40 quid a replacement. It's going to add up. So that's always like 500 quid. What else we got? Bathroom downlight not IP rated, so we said that at the start, so that needs swapping over. So what, they're like 20, 30 quid a fitting, something like that, depending what brand you go with. So we'll get that swapped over. What else have we got? We've got a lot of stuff needs moving onto the RCD side, so we can do that, fair enough. When we do move it over, we're going to put like the bar, remember the bar socket was in with the 32 amp, so you had potentially a big fire risk there. So we're going to move that over onto that side as well, and stop that coming out of the 32 and make that come out of a 20 amp, which will protect it. It sets on fire at 27, so it wants to trip at 20 before that can even set on fire. Well, so we've got no earth to conservatory light, so we'll have to take that down and see why. No earth to 2 outside lights, and no earth to that top bedroom light. And that is everything. So yeah, these new builds, he said it's been like that since day dot. So it's been built in 2005, and yeah, there's just loads of issues with it. And then he's had that bar added, and whoever's done that bar don't know what they're doing, because obviously any electrician knows you can only come off once off a ring, and it's come off and come off and come off and come off. And I doubt he's even got a certificate with that, so he's probably just done some dodgy cash job, run off with the money, and potentially could set fire to the customer's house. So yeah, let me know below then if you'd do anything different testing wise, or if you code things any differently. So some people are a lot more stricter than me, or a lot less stricter. It's interesting because it's down to the engineer really. Obviously we've got us like, I don't know, NIP, they've got a document, I can't remember what it's called now, but basically it's code busters, I think it's called, and it basically tells you what code to code things of what they think. But at the end of the day, it's down to your it's down to the electrician really to determine that. So because it'll be, they're liable for saying it's safe. So if they're saying it, you know what I mean, this certain thing or this certain issue is going to be fine, then it's on them. So really the regulation is just like a guide really to help you give the best advice and to help you back up stuff like this. So I've just talked about the customer with the fire at downlights. It's the regulation. I can send him the regulation, and that'll help me back up my argument of why I've said and deemed that circuit to be bad. Whew, so look at that, 21 degrees. Things have got a little bit cooler then. So yeah, I think it's time for a bit of munch, yeah? Hey, I've just dropped in the family calf. Look at this. Looking good. Yeah. Was it baked beans on toast with eggs?
Baked beans with baby sausages in our coffee today.
Lovely. Very nice, thank you very much. Look at that, very nice. Can't wait for that then. I have to mark it. I have to get a good mark, it's family. Good. That's supposed to be an okay. Very nice, very nice. Well, hey, so we're picking up as donated barbecue for summer. Look at that, that'll do. I'll get that out, get some nice little sausages on there. Well, hey, the barbie's been on then, so sausages, burgers, little family party watching the England game, which is not going very well so far. What is it, 1-0 to Slovakia, a bit of karaoke. Hey, but yeah, it's been a good day. A bit of bonus footage then. So I've been putting up these uplighters then. So we've wired those in with an armed cable to a little whisker box gland, and then we've got like a little wireless switch then. So it's a 3-gang switch. So we've got the tree lights on one, we've got the spark lights on 2, and then we've got a third option, which will be the water feature at the bottom. So I'll show you that in a bit. Oh, look at that bicycle kick!
Watch it!
That is a bicycle kicking out. There we go, that's those lights on then. So I don't think GoPros pick up the light all that well. It's looking great. Obviously we've got a bit of garden work to do, but look. It's a lot better in real life than looking on this, but yeah, it's looking great. This floodlight's going to ping on over and everything. Nah, it's washed it all out, hasn't it? On this floodlight. Yeah, good result. England absolutely smashed it, 2-1. What a comeback from 1-0 on the what do you call it, injury time. Absolutely killed it, but yeah. Yeah, a big difference there, it's just pitch black. That's that connect switch I'm talking about. So this wirelessly connects up to a switch in the garage. And yeah, it works up to 70 metres away, which is pretty cool. Yeah, that's those on. Ping. Yeah, big difference before and after really. little bonus footage for you. So that's all I've got time for today's video then. Let's stand somewhere you can actually see me and the mystical tree. So yeah, so we had a dodgy one. It was quite a while ago now because I'm filming this way after. I thought I'd give you a bit of bonus footage. So we had them dodgy, what were they? The light fits that weren't earthed. So Hayden's actually been back there now with Ellis and actually sorted all that out now. So yeah, basically the bloke didn't want the outside lights earthing, so we've actually just disconnected those. So that's what we did for there. And then the light in the conservatory, whoever put that conservatory up they didn't get electrician in at all because it wasn't earthed and the switch was earthed. So there'll be some dodgy joint connection with like a little pot pie box there in the middle probably. But yeah, we basically swapped it out for a plastic fitting, so the customer happy anyway because he could take that to his new house, so that was a bonus for him. But yeah, that's all I've got time for this video then. So if you like this kind of content, hit the like button, hit subscribe, hit the little bell notification so you know when next upload. So as always, have good from me, and I'll see you on the next one. Thank you.